Hi again. I'm making lots of videos today. I'm bringing this one up because I sent it to you in an email. This is a probability distribution chart with all the really important distributions and the ones that we talk about in this class and even some extras. But this sheet a friend of mine in graduate school made, and I've always kept it. I don't even have a electronic copy of it. I just have this paper copy I keep making more and more copies of. But I just find it really useful as a summary of some of the really important random variables that we talk about, and everything that you'll need to know about them is summarized. And definitely, this is always legal to use on tests, assignments, homework, anything. So, even on your upcoming test, you want to make sure to have a copy of this and use it. I'm not one for memorizing, so I mean these I feel very good about, but some of the aspects of them, like moment generating functions, I certainly don't memorize everything. So I think it's a really nice chart to always have handy now, especially even when you do the homework in chapter 5 and chapter 6. So I'm just going to point out that just already for discrete, you should well be familiar with actually most of these. So let's see. The first random variable we talked about, I'm not sure if this is going to work or not, but well, even if it doesn't, which it doesn't, uh, the Bernoulli random variable was the first one we introduced. I introduced, period, that it's just you do something once and either it's a success or failure. Support is either, again, success or failure. The probability of success or failure is between 0 and 1. The mass function right there is either succeed or fail. Well, you don't know moment generating function yet, but the mean of a Bernoulli is p. Here's the variance. So these are all the popular ones. Another one, wow, I wish that, I don't know, I kind of wish that would work. That would look kind of nice, huh? Well, oh, oh, here's something. Well, anyways, I'm just wasting your time, right? Okay, well, here's the other. The first one we did, this was section 5.1, was the binomial number. And I really like these notes here. Just every random variable is a story. The binomial story is number of successes and n tries. You do something n times, how many times were you successful? This is very nice foul shooting, I think, example. Support, number of successes could be from 0 to n, since you do it n times. There's the mass function. Again, here's the mean, here's the variance. Geometric, number of times until you get a success, could be 1, 2, 3. Here's the mass function. Again, here's the mean, 1 over p. Here's the variance. Negative binomial, number of trials till you get r successes. Poisson, number of events in time or space. Hypergeometric, without replacement version of binomial. So you're still counting number of successes, but you're not replacing items back into your pool. I rewrote it a little bit down here because I don't think of M and N as your goods and bads. I usually call D is the number of defectives, and then capital N minus D is the number of goods. But same deal, there's mean and variance. We didn't do a trinomial, but it's very much like the binomial. So actually this is a good review of chapter 5. Here are all the density functions. There's that lambda x e to the negative lambda for the Poisson. So you can see this is a very handy table. And moving into chapter 6, we're not going to knock off as many of these as I'd like to, just for time reasons. And again, if you take another course in probability or even statistics, you might see more of these. In 7.1, if you're that far, that's what we started this week, is the uniform random variable is just 1 over b minus a. It's a really nice, equally likely, everyone in the interval. So there's the uniform. Yeah, I'm sorry, he put that there. Distribution of maximum ignorance. Okay, it's just, yeah, 1 over a fourth. That's bad. A fourth, a fifth. It's just a nice flat linear function. Exponential is often amount of time before something happens. Erlang we'll see a little bit later. Chi-square you might have seen in statistics. Gamma you might have seen in statistics. Beta, Weibel. The ones we'll do are uniform, exponential, here's their density functions. We call them density when they're continuous, we call them mass when they're discrete, but same deal. Here's the other big one, normal. I think that's what was on tap for yesterday was the normal, right? Section 7.2. So 7.1 was uniform, normal 7.2. There's the density function. Make sure that you see that sigma doesn't go under the square root there. It's not very, wish it was more clear. Sometimes I put sigma out front so you see it's not under that square root. Again, there's the mean, there's the variance. So this is handy for discrete and continuous. And I forgot, I think that if I have that last page, this was a chart I was working on with my advisor. This is just a, which way I should rotate it? Let's see, counterclockwise, yeah. So this just shows a relationship between random variables. There's millions and millions of random variables, right? And we only hit the big ones, but you can see a lot of them are based, or maybe even, I don't want to say based on each other, but some of them are, as n goes to infinity, or if you add random variables, or if you take a limit of this as n goes to infinity. So there's lots of connections, and that's what we were trying to show relationships down here. So, for example, it was Michael that sent that email about the connection between the geometric and the negative binomial. Where is that guy? It should be down here, right? If we find one of them, where is the, I don't see the geometric, maybe you do, but there should be a line between geometric and negative binomial. I thought like toward the top is more your continuous, and well, there's your hypergeometric up there. Oh, that's a negative hypergeometric. Poisson binomial. Binomial goes to Poisson, right? I mean, these are two, you've already seen that binomial and Poisson, how they're related. Why is the geometric not around here? I don't know, but whenever you find it, it should have a connection between the negative binomial. I really don't see it. I mean, obviously it's here somewhere, but I'm just not doing a very good job. So what's the point? It's kind of a cool chart. I have a big poster of it in my office if you ever want to see, or if you want to buy one, I know where we can get a nice poster of this. It's kind of impressive, I think. So, oh, here's my geometric, yay! And where's my negative binomial? Oh, no, Pascal for n equals 1. Maybe that's I didn't know, I don't know, could Pascal be called the negative binomial in another world, and I don't know. Oh well, that's a shame, huh? Anyway, I'll stop this one. I think I'll make one more of a normal table and then call it quits for today. Okay.